about constructing confidence intervals for p hat. So again, the assumptions that we're going to make is that the data was collected was a simple random sample. The number of successes and the number of failures are both greater than 5. So we do a little check. All those conditions are met. Then we can construct our confidence interval using p hat plus or minus. And notice now, since we have all this normality, the nice thing about proportions, everything's going to follow the normal distribution for proportions. You don't have to worry about checking for a z or a t. It's always going to be a z. So we're good to go there. So we have p hat plus or minus z alpha over 2, and then we just throw in our estimators like we did before with x bar, and we're off and running, and we can do our confidence interval. Do that. Come back here to our opening example. So if you want to just flip back a couple of slides, since we want to compute a 95% confidence interval, we know that the confidence interval then is in the form of p hat plus or minus z alpha over 2 times the square root of p hat times 1 minus p hat. All that's divided by n. So in this case, we have n, in this case, is 200. X is equal to 162. And I hope everybody will agree with me that x is greater than 5. Do we agree? And if I take 200 minus 162, that's greater than 5. So the requirements are met. So now all we have to do is substitute 162 over 200 plus or minus. So now we need our z alpha over 2. It's 1.96, sorry. I even have it written down right here. Come on, that's crazy, isn't it? So then we go 162 divided by 200 times 1 minus 162 divided by 200. And I think I'm just going to write it this way, divided by n. And I'm going to put a bracket here, and I'm going to put a bracket here. The reason why I'm doing this is I want you to see how to enter it into the calculator so that we don't have any computational issues when it comes to our computation. So I'm going to go ahead and pull up my calculator here, and just to make sure if you guys want to follow along with the computation here, and then we'll just discuss some of the other stuff as we go along. So I'm just going to go open bracket, and then I don't need to do open bracket. So I'm just going to go 162 divided by 200, and I always like to start with the lower bound, so I'm going to go minus 1.96, and now this is where we have to be careful with our bracketing, unless you guys have the newer 84s where it just kind of follows along in there. So I'm going to go square root, and then notice I get that bracket, that opening bracket is this guy right here. Okay, so now all I got to do is just go another open bracket, 162 divided by 200, close, open bracket, 1 minus 162 divided by 200, close bracket, and then I'm just going to go divided by 200, and then I'm going to do one more close bracket. So that puts everything right here exactly the way I want to enter it into here, so I can't make sure I got all my brackets and everything taken care of. So come up with 0.7556, and so I don't have to re-enter all of that stuff. We'll just go second enter, and then I'm just going to arrow up and change that subtraction sign to a plus sign, and we get 0.8647. So our 95% confidence interval then is 0.7556, comma 0.8644. And if we need to interpret this, this is exactly the same way we've been interpreting confidence intervals since chapter 8. So we can come back and say that we are 95% confident that the true proportion of people that are satisfied with their job is between 0.7556 and 0.8644.